Hey there, Seahawks, it's Miss Adams, and in this video, we're going to learn about discrete random variables. All right, so a random variable can be two different types of random variable. We have a discrete random variable, which is made up of distinct or very specific values. A lot of times these don't have decimals, but they can have decimals. It's just they're not taking on a whole range. So it's like 2.5, 3, 3.5, 4. If it is decimals, like there's kind of like specific ones that it can be. It can't just be any value between like 1 and 1.1, all right? And then there are continuous random variables. They can take on any value within an interval. So they could be 1, 1.00001, 1.0002, and so on. Like it could be any value. When naming random variables, we typically use capital letters, all right? So make a discrete probability distribution for the random variable x, all right? So that's our random variable's name. We're calling it x, and then we're defining x as the number of heads after 3 flips of a fair coin, all right? So we've looked at this before when we did probabilities. So if we have 3 flips of a fair coin, I could get heads, heads, heads. I could get heads, heads, tails. I could get heads, tails, heads. I could get tails, heads, heads. I could get heads, tails, tails. I could do tails, heads, tails. I could do tails, tails, heads, or tails, tails, tails. Those are all of the possibilities. All right, so the number of heads after 3 flips of a fair coin, well, I could have 0 heads. So the probability that x, the number of heads after 3 coin flips, is equal to 0, there's only one outcome out of 8 total outcomes there. So 1 out of 8, the probability that x is equal to 0. The probability that I have exactly 1 head out of 3 flips are 3 of these 8 outcomes, so 3/8. Probability that I have 2 heads, again, is 3, so 3 out of 8. And the probability that I have 3 heads is 1 out of 8. All right, so now I'm going to graph this. All right, so I'm making a probability distribution. So I'm going to have probability on my y-axis. The bottom, I have my value of x. And remember, x is the number of heads after 3 flips of a fair coin. All right. Since everything is counting by 8s, I'm going to go up 8 tick marks, and that will be 1. All right, so this first one is 1/8. All right, all the way up until 8/8, which is equal to 1 whole. All right, so for the first one, when I have 0, I'm at 1/8. If I have 1 head, I'm at 3/8. If I have 2 heads, I'm at 3/8. And if I have 3 heads, I'm at 1/8. So that is what my discrete probability distribution looks like as a histogram. All right, probability with discrete random variables. So Miss Adams buys mystery puppy dog pal toys until she gets Isaac's favorite puppy, but she only has enough money to buy at most 4 packs. Suppose each pack has a probability of 0.2 of containing the pup Isaac is hoping for. Let X be the number of puppy packs Miss Adams buys. Find the probability that X is greater than or equal to 3. All right, so what I'm trying to find is the probability that I buy 3 or more packs. Well, it says I have at most enough money to buy 4. So once I get to 4, I'm going to stop. It's not going to continue. Okay? So in order for me to figure that out, I need to figure out what's the probability of getting it 4. Also, the first one, when I buy just 1, the probability that I stop there is 0.2 because there's a 20% chance that I will get that pup on the first try. The next one, when I do 2, well, the first time I didn't get it, which means there's a 0.8 chance of not getting it because there's a 0.2 chance of getting it, times getting it on the second time, which is 0.2. So that's 0.8 times 0.2. That's where that came from. Okay. But we don't need to really figure that out. We know that if this is going to be a valid probability model, all values have to be values between 0 and 1, and the probabilities have to add up to 1. So I'm going to do 1 minus the other values that I already have probabilities for. So 1 minus 0.2 minus 0.16 minus 0.128 gives me 0.512. All right, so there's a 51.2% chance that I will get to 4. Maybe I get it, maybe I don't. But that's the probability that I have to buy 4 packs. Whether or not I actually get the puppy, maybe, maybe not. All right, so the probability that x is greater than or equal to 3 would be the probability that it's 3 or the probability that it's 4. So I'm just going to add those together, and I get 0.64, which is 64% chance that I will buy 3 or 4 puppy packs. All right, find the mean and standard deviation for a discrete random or discrete probability distribution. Let W equal the number of workouts in a week. Use the probability distribution given to find the expected value and the standard deviation of workouts in a week. Okay, so to find the expected value is basically just the mean. So E of W, the expected value of the number of workouts, is equal to the mean of the number of workouts. And that symbol there is mu. It is the Greek letter that stands for mean. All right, so I'm going to do 0 times its probability, which is 0.1, plus 1 times its probability, which is 0.15, plus 2 times its probability of 0.4, plus 3 times its probability of 0.25, plus 4 times its probability of 0.1. So I'm going to multiply them, add them, put in my calculator, I get 2.1 as my mean or my expected value. Okay? What that means is I would expect to work out, I would expect to have 2.1 workouts a week. Now, that doesn't make sense when we're talking about just 1 week, but when we're finding a average, it's over many, many weeks. Okay? So if I collected data for 100 weeks, then I would expect to work out 21 times out of 100 weeks. Okay, so that's how that works. An average can be a decimal even though it does not make sense in that certain situation. Summary statistics. All right, so now I want to find the standard deviation. So to find the standard deviation, I'm going to start with the variance. So for the variance, I'm going to take each value, subtract the mean, square it, and times it by its probability. So I'm doing 0 minus the mean, 2.1, square that, and times it by the probability of 0, which is 0.1. Plus the next one, 1 minus the mean, squared, times its probability, 0.15. Plus the next one, 2 minus the mean, 2.1, squared, times its probability, 0.4. Plus 3 minus the mean, squared, times its probability, plus 4 minus the mean, squared, times its probability. This works out to 1.19. Now that is the variance of W. I want to find the standard deviation, so I am going to take the square root of the variance because that's how you get the standard deviation, which gives me 1.09. All right, go Seahawks.